Finding the vertex of the graph of a parabola. So let's look at this equation first. So from here we know that the roots is going to be -6 or 7. So that means that we'll have a parabola that's going to hit, the roots is going to be -6 on x-axis and 7 here. And by just looking at the coefficient of x squared, right? So if you expand this, you're going to have x squared plus something. By just looking at this, coefficient of x is positive, so the parabola is going to open upwards like this, something like this, right? And we try to find the vertex, which is the minimum in this case. Well, we know that parabola is symmetric, so that we should have the line of symmetry like this, right? Line of symmetry hits somewhere in the middle of -6 and 7, which can be found by finding the average of these two numbers. So how do we find the average of -6 and 7? Going back to like 5th grade or 6th grade, maybe a little before that, you're going to get -6 plus 7. You add these two numbers and divide it by 2, because we have two numbers. So that's going to be a half. So that's going to be a half. That's going to be x coordinates, right? So we know x coordinate is going to be a half. And then we're going to have to find the y-axis, or the y coordinates. What would be the number? All we have to do is just plug this number in there and here. So we're going to have half plus 6, and then half minus 7. That's going to be 13 halves, right? And because this is 12 over 2, now this is 14 over 2. It's easier to do that. That's going to be 13 over 2 as well. Negative 13 over 2, right? Yeah, I'm doing right. So if you multiply these two numbers, you're going to get -169 over 4. That's going to be probably 42 something. 42 and a quarter. So that's going to be the y coordinates. That's going to be 169 over 4. I prefer to leave it as a fraction. So what if we have different form like this? So we can use the the fact that the vertex of the parabola is the average of that, average of two roots, or if the in ax squared, we call that standard form, bx plus c equals 0, then the average of the roots will be negative b, opposite of b over 2a, right? So that comes from the sum of roots theorem. We know that the sum of roots theorem from the previous video, we know that that's going to be the opposite of b over a. So now in this case, a is -4, b is 7, that's b. So let's plug that in here. So opposite of b, which is 7, over 2 times a, which is -4. Make sure to use that parentheses so that you won't get tricked. So now we get opposite of 2 over -8. So opposite of this guy is going to be just 7/8. So that's going to be the x coordinates of that. So this equation, since the coefficient is negative, it's going to open downwards. So we don't know the roots here, but we know that line of symmetry hits 7/8. So x coordinates is going to be 7/8, and we got to plug that back in. So we have y equals -4 times 7/8 squared plus 7 times 7/8 plus 2. doing some calculation, you get 49 over 64 plus 49 over 8 plus 2. Having a coefficient, the denominator, common denominator, we're going to get 1 over 64, negative 4 times this guy, negative 196, all right? Plus we gotta multiply by this 8 over 8. 392, and then you're gonna multiply by 64 over 64. So that's gonna be 128. What is that? What are we gonna get? 3292128 minus 196, 423, 324 over 64, which can be reduced. I'm pretty sure that I can divide it by 8 over 8. That's gonna give me, no, probably not. 4 over 4. It's going to be 81 over 16. So that's going to be the y coordinate. So the computation looks a little messy, but whole point is use if the quadratic is in this form, use this guy, opposite of b over 2a, which is the average of the roots. Find the x-axis. That's going to give you the x coordinate right away, and all you have to do just put the x coordinate or x value back into this x and do some calculation carefully, then you're going to get y coordinates.